Saturn Universe defined. Saturn is the sixth planet from the Sun and the second largest in the solar system after Jupiter. It is a gas giant with an average radius of about 9.5 times that of Earth. It has only 1/8 the average density of Earth, however, with its larger volume, Saturn is over 95 times more massive. Saturn's interior is most likely composed of a core of iron-nickel and rock silicon and oxygen compounds. Its core is surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and finally, a gaseous outer layer. Saturn has a pale yellow hue due to ammonia crystals in its upper atmosphere. An electrical current within the metallic hydrogen layer is thought to give rise to Saturn's planetary magnetic field, which is weaker than Earth's, but which has a magnetic moment 580 times that of Earth due to Saturn's larger size. Saturn's magnetic field strength is around 1/20th of Jupiter's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1800 km/h 1100 mph, 500 m/s, higher than on Jupiter but not as high as on Neptune. The planet's most notable feature is its prominent ring system, which is composed mainly of ice particles, with a smaller amount of rocky debris and dust. At least 83 moons are known to orbit Saturn, of which 53 are officially named. This does not include the hundreds of moonlets in its rings. Titan, Saturn's largest moon and the second largest in the solar system, is larger than the planet Mercury, although less massive, and is the only moon in the solar system to have a substantial atmosphere. Name and symbol. Saturn is named after the Roman god of wealth and agriculture and father of Jupiter. Its astronomical symbol has been traced back to the Greek Oxyhenchus papyri, where it can be seen to be a Greek Kappa with a horizontal stroke, as an abbreviation for Kappa Omicron Nu Omicron Sigma Cronus, the Greek name for the planet. It later came to look like a lower-case Greek eta, with the cross added at the top in the 16th century to Christianize this pagan symbol. The Romans named the seventh day of the week Saturday, Saturni dies, Saturn's day, for the planet Saturn. Physical characteristics. Saturn is a gas giant composed predominantly of hydrogen and helium. It lacks a definite surface, though it is likely to have a solid core. Saturn's rotation causes it to have the shape of an oblate spheroid, that is, it is flattened at the poles and bulges at its equator. Its equatorial and polar radii differ by almost 10%, 60,268 km versus 54,364 km. Jupiter, Uranus, and Neptune, the other giant planets in the solar system, are also oblate but to a lesser extent. The combination of the bulge and rotation rate means that the effective surface gravity along the equator, 8.96 m/s2, is 74% of what it is at the poles and is lower than the surface gravity of Earth. However, the equatorial escape velocity of nearly 36 km/s is much higher than that of Earth. Saturn is the only planet of the solar system that is less dense than water, about 30% less. Although Saturn's core is considerably denser than water, the average specific density of the planet is 0.69 g/cm3 due to the atmosphere. Jupiter has 318 times Earth's mass, and Saturn is 95 times Earth's mass. Together, Jupiter and Saturn hold 92% of the total planetary mass in the solar system. Internal structure. Despite consisting mostly of hydrogen and helium, most of Saturn's mass is not in the gas phase because hydrogen becomes a non-ideal liquid when the density is above 0.1 g/cm3, which is reached at a radius containing 99.9% of Saturn's mass. The temperature, pressure, and density inside Saturn all rise steadily toward the core, which causes hydrogen to be a metal in the deeper layers. Standard planetary models suggest that the interior of Saturn is similar to that of Jupiter, having a small rocky core surrounded by hydrogen and helium, with trace amounts of various volatiles. Analysis of the distortion shows that Saturn is substantially more centrally condensed than Jupiter and therefore contains a significantly larger amount of material denser than hydrogen near its center. Saturn's central regions contain about 50% hydrogen by mass, while Jupiter's contain approximately 67% hydrogen. This core is similar in composition to Earth, but is more dense. The examination of Saturn's gravitational moment, in combination with physical models of the interior, has allowed constraints to be placed on the mass of Saturn's core. In 2004, scientists estimated that the core must be 9-22 times the mass of Earth, which corresponds to a diameter of about 25,000 km. However, measurements of Saturn's rings suggest a much more diffuse core with a mass equal to about 17 Earths and a radius equal to around 60% of Saturn's entire radius. This is surrounded by a thicker liquid metallic hydrogen layer, followed by a liquid layer of helium-saturated molecular hydrogen that gradually transitions to a gas with increasing altitude. The outermost layer spans 1,000 km and consists of gas. Saturn has a hot interior reaching 11,700 degrees C at its core and radiates 2.5 times more energy into space than it receives from the Sun. Jupiter's thermal energy is generated by the Kelvin-Helmholtz mechanism of slow gravitational compression, but such a process alone may not be sufficient to explain heat production for Saturn because it is less massive. An alternative or additional mechanism may be generation of heat through the raining out of droplets of helium deep in Saturn's interior. As the droplets descend through the lower density hydrogen, the process releases heat by friction and leaves Saturn's outer layers depleted of helium. These descending droplets may have accumulated into a helium shell surrounding the core. Rainfalls of diamonds have been suggested to occur within Saturn, as well as in Jupiter and ice giants Uranus and Neptune. Atmosphere. The outer atmosphere of Saturn contains 96.3% molecular hydrogen and 3.25% helium by volume. The proportion of helium is significantly deficient compared to the abundance of this element in the Sun. The quantity of elements heavier than helium metallicity is not known precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system. The total mass of these heavier elements is estimated to be 19-31 times the mass of the Earth, with a significant fraction located in Saturn's core region. Trace amounts of ammonia, acetylene, ethane, propane, phosphine, and methane have been detected in Saturn's atmosphere. The upper clouds are composed of ammonia crystals, while the lower level clouds appear to consist of either ammonium hydrosulfide and H4SH or water. Ultraviolet radiation from the Sun causes methane photolyses in the upper atmosphere, leading to a series of hydrocarbon chemical reactions with the resulting products being carried downward by eddies and diffusion. This photochemical cycle is modulated by Saturn's annual seasonal cycle. Cassini observed a series of cloud features found in northern latitudes, nicknamed the String of Pearls. These features are cloud clearings that reside in deeper cloud layers. Cloud layers. Saturn's atmosphere exhibits a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and are much wider near the equator. The nomenclature used to describe these bands is the same as on Jupiter. Saturn's finer cloud patterns were not observed until the flybys of the Voyager spacecraft during the 1980s. Since then, Earth-based telescopy has improved to the point where regular observations can be made. The composition of the clouds varies with depth and increasing pressure. In the upper cloud layers, with the temperature in the range 100-160 K and pressures extending between 0.5-2 bar, the clouds consist of ammonia ice. Water ice clouds begin at a level where the pressure is about 2.5 bar and extend down to 9.5 bar, where temperatures range from 185 to 270 K. Intermixed in this layer is a band of ammonium hydrosulfide ice, lying in the pressure range 3-6 bar with temperatures of 190-235 K. Finally, the lower layers, where pressures are between 10 and 20 bar and temperatures are 270-330 K, contains a region of water droplets with ammonia in aqueous solution. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope imaged an enormous white cloud near Saturn's equator that was not present during the Voyager encounters, and in 1994 another smaller storm was observed. The 1990 storm was an example of a great white spot, a unique but short-lived phenomenon that occurs once every Saturnian year, roughly every 30 Earth years, around the time of the Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, and 1960, with the 1933 storm being the most famous. If the periodicity is maintained, another storm will occur in about 2020. The winds on Saturn are the second fastest among the solar system's planets after Neptune's. Voyager data indicate peak easterly winds of 500 m/s/1800 km/h. In images from the Cassini spacecraft during 2007, Saturn's northern hemisphere displayed a bright blue hue, similar to Uranus. The color was most likely caused by Rayleigh scattering. Thermography has shown that Saturn's south pole has a warm polar vortex, the only known example of such a phenomenon in the solar system. Whereas temperatures on Saturn are normally -185°C, temperatures on the vortex often reach as high as -122°C, suspected to be the warmest spot on Saturn. Hexagonal cloud patterns. A persisting hexagonal wave pattern around the north polar vortex in the atmosphere at about 78 degrees N was first noted in the Voyager images. The sides of the hexagon are each about 14,500 km, 9,000 mile long, which is longer than the diameter of the Earth. The entire structure rotates with a period of 1039 the same period as that of the planet's radio emissions, which is assumed to be equal to the period of rotation of Saturn's interior. The hexagonal feature does not shift in longitude like the other clouds in the visible atmosphere. The pattern's origin is a matter of much speculation. Most scientists think it is a standing wave pattern in the atmosphere. Polygonal shapes have been replicated in the laboratory through differential rotation of fluids. HST imaging of the south polar region indicates the presence of a jet stream, but no strong polar vortex nor any hexagonal standing wave. NASA reported in November 2006 that Cassini had observed a hurricane-like storm locked to the South Pole that had a clearly defined eye wall. Eye wall clouds had not previously been seen on any planet other than Earth. For example, images from the Galileo spacecraft did not show an eye wall in the Great Red Spot of Jupiter. The South Pole storm may have been present for billions of years. This vortex is comparable to the size of Earth, and it has winds of 550 km/h. Magnetosphere. Saturn has an intrinsic magnetic field that has a simple, symmetric shape, a magnetic dipole. Its strength at the equator 0.2 Gauss micro-T is approximately 1/20th of that of the field around Jupiter and slightly weaker than Earth's magnetic field. As a result, Saturn's magnetosphere is much smaller than Jupiter's. When Voyager 2 entered the magnetosphere, the solar wind pressure was high and the magnetosphere extended only 19 Saturn radii, or 1.1 million km 712,000 mi, although it enlarged within several hours and remained so for about 3 days. Most probably, the magnetic field is generated similarly to that of Jupiter by currents in the liquid metallic hydrogen layer called a metallic hydrogen dynamo. This magnetosphere is efficient at deflecting the solar wind particles from the Sun. The moon Titan orbits within the outer part of Saturn's magnetosphere and contributes plasma from the ionized particles in Titan's outer atmosphere. Saturn's magnetosphere, like Earth's, produces aurorae. Orbit and rotation. The average distance between Saturn and the Sun is over 1.4 billion kilometers 90, with an average orbital speed of 9.68 km/s. It takes Saturn 10,759 Earth days, or about 29 plus 2 years, to finish one revolution around the Sun. As a consequence, it forms a near 5-to-mean motion resonance with Jupiter. The elliptical orbit of Saturn is inclined 2.48 degrees relative to the orbital plane of the Earth. The perihelion and aphelion distances are, respectively, 9.195 and 9.957 on average. The visible features on Saturn rotate at different rates depending on latitude, and multiple rotation periods have been assigned to various regions as in Jupiter's case. Astronomers use 3 different systems for specifying the rotation rate of Saturn. System I has a period of 1014 zeros 844.3 degrees/d and encompasses the equatorial zone, the south equatorial belt, and the north equatorial belt. The polar regions are considered to have rotation rates similar to System I. All other Saturnian latitudes, excluding the north and south polar regions, are indicated as System Roman II and have been assigned a rotation period of 1038 20 5.4 810.76 degrees/d. System Roman III refers to Saturn's internal rotation rate. Based on radio emissions from the planet detected by Voyager 1 and Voyager 2, System Roman III has a rotation period of 1039 20 2.4 810.8 degrees/d. System Roman III has largely superseded System Roman II. A precise value for the rotation period of the interior remains elusive. While approaching Saturn in 2004, Cassini found that the radio rotation period of Saturn had increased appreciably to approximately 1045 45 plus or minus 36. An estimate of Saturn's rotation as an indicated rotation rate for Saturn as a whole based on a compilation of various measurements from the Cassini, Voyager, and Pioneer probes is 1032-35. Studies of the planets C ring yield a rotation period of 1033-38 plus 152 minus 119s. In March 2007, it was found that the variation of radio emissions from the planet did not match Saturn's rotation rate. This variance may be caused by geyser activity on Saturn's moon Enceladus. The water vapor emitted into Saturn's orbit by this activity becomes charged and creates a drag upon Saturn's magnetic field, slowing its rotation slightly relative to the rotation of the planet. An apparent oddity for Saturn is that it does not have any known Trojan asteroids. These are minor planets that orbit the Sun at the stable Lagrangian points, designated L4 and L5, located at 60 degrees angles to the planet along its orbit. Trojan asteroids have been discovered for Mars, Jupiter, Uranus, and Neptune. Orbital resonance mechanisms, including secular resonance, are believed to be the cause of the missing Saturnian Trojans. Natural satellites. Saturn has 83 known moons, 53 of which have formal names. In addition, there is evidence of dozens to hundreds of moonlets with diameters of 40-500 meters in Saturn's rings, which are not considered to be true moons. Titan, the largest moon, comprises more than 90% of the mass in orbit around Saturn, including the rings. Saturn's second largest moon, Rhe, may have a tenuous ring system of its own, along with a tenuous atmosphere. Many of the other moons are small. 34 are less than 10 km in diameter and another 14 between 10 and 50 km in diameter. Traditionally, most of Saturn's moons have been named after titans of Greek mythology. Titan is the only satellite in the solar system with a major atmosphere in which a complex organic chemistry occurs. It is the only satellite with hydrocarbon lakes. On 6 June 2013, scientists at the IAA-CSIC reported the detection of polycyclic aromatic hydrocarbons in the upper atmosphere of Titan, a possible precursor for life. On 23 June 2014, NASA claimed to have strong evidence that nitrogen in the atmosphere of Titan came from materials in the Oort cloud associated with comets, and not from the materials that formed Saturn in earlier times. Saturn's moon Enceladus, which seems similar in chemical makeup to comets, has often been regarded as a potential habitat for microbial life. Evidence of this possibility includes the satellite's salt-rich particles having an ocean-like composition that indicates most of Enceladus's expelled ice comes from the evaporation of liquid salt water. A 2015 flyby by Cassini through a plume on Enceladus found most of the ingredients to sustain life forms that live by methanogenesis. In April 2014, NASA scientists reported the possible beginning of a new moon within the ring, which was imaged by Cassini on 15 April 2013. Planetary rings. Saturn is probably best known for the system of planetary rings that makes it visually unique. The rings extend from 6,630 to 120,700 kilometers, 4,120 to 75,000 mi outward from Saturn's equator and average approximately 20 meters, 66 ft in thickness. They are composed predominantly of water, ice with trace amounts of fallen impurities and a peppered coating of approximately 7% amorphous carbon. The particles that make up the rings range in size from specks of dust up to 10 m. While the other gas giants also have ring systems, Saturn's is the largest and most visible. There are two main hypotheses regarding the origin of the rings. One hypothesis is that the rings are remnants of a destroyed moon of Saturn, for which a research team at MIT has proposed the name chrysalis. The second hypothesis is that the rings are left over from the original nebular material from which Saturn was formed. Some ice in the E-ring comes from the moon Enceladus's geysers. The water abundance of the rings varies radially, with the outermost ring being the most pure in ice water. This abundance variance may be explained by meteor bombardment. Beyond the main rings, at a distance of 12 million km from the planet, is the sparse Phoebe ring. It is tilted at an angle of 27 degrees to the other rings and, like Phoebe, orbits in retrograde fashion. Some of the moons of Saturn, including Pandora and Prometheus, act as shepherd moons to confine the rings and prevent them from spreading out. Pan and Atlas cause weak, linear density waves in Saturn's rings that have yielded more reliable calculations of their masses. History of observation and exploration. The observation and exploration of Saturn can be divided into three phases. The first phase is ancient observations such as with the naked eye, before the invention of modern telescopes. The second phase began in the 17th century with telescopic observations from Earth, which improved over time. The third phase is visitation by space probes in orbit or on flyby. In the 21st century, telescopic observations continue from Earth, including Earth-orbiting observatories like the Hubble Space Telescope and, until its 2017 retirement, from the Cassini orbiter around Saturn. Ancient observations. Saturn has been known since prehistoric times, and in early recorded history it was a major character in various mythologies. Babylonian astronomers systematically observed and recorded the movements of Saturn. In ancient Greek, the planet was known as Phaeon, and in Roman times it was known as the star of Saturn. In ancient Roman mythology, the planet Phaenon was sacred to this agricultural god, from which the planet takes its modern name. The Romans considered the god Saturnus the equivalent of the Greek god Cronus in modern Greek. The planet retains the name Cronus Capra Omicron Nu Omicron Sigma, Chronos. The Greek scientist Ptolemy based his calculations of Saturn's orbit on observations he made while it was in opposition. In Hindu astrology, there are 9 astrological objects known as Navagrahas. Saturn is known as Shani and judges everyone based on the good and bad deeds performed in life. Ancient Chinese and Japanese culture designated the planet Saturn as the Earth star Chinese letter. This was based on 5 elements, which were traditionally used to classify natural elements. In ancient Hebrew, Saturn is called Shabbathai. Its angel is Cassiel. Its intelligence or beneficial spirit is Agil Hebrew, Hebrew Aleph, Gimel Yud Aleph Lamed, Romanized, letter 2 GYL, and its darker spirit demon is Zazel Hebrew, Hebrew Zain Aleph, Zain Lamed, Romanized, Zazel. Zazel has been described as a great angel invoked in Solomonic magic who is effective in love conjurations. In Ottoman Turkish, Urdu, and Malay, the name of Zazel is Zuhal, derived from the Arabic language Arabic Zain Het Lam, Romanized, Zuhal. European observations 17th–19th centuries. Saturn's rings require at least a 15 mm diameter telescope to resolve and thus were not known to exist until Cassini-Huygens saw them in 1655 and published about this in 1659. Galileo, with his primitive telescope in 1610, incorrectly thought of Saturn's appearing not quite round as 2 moons on Saturn's sides. It was not until Huygens used greater telescopic magnification that this notion was refuted, and the rings were truly seen for the first time. Huygens also discovered Saturn's moon Titan, Giovanni D'Amico. Cassini later discovered 4 other moons, Iapetus, Rhe, Tethys, and Dione. In 1675, Cassini discovered the gap now known as the Cassini division. No further discoveries of significance were made until 1789, when William Herschel discovered 2 further moons, Mimas and Enceladus. The irregularly shaped satellite Hyperion, which has a resonance with Titan, was discovered in 1848 by a British team. In 1899, William Henry Pickering discovered Phoebe, a highly irregular satellite that does not rotate synchronously with Saturn as the larger moons do. Phoebe was the first such satellite found, and it takes more than a year to orbit Saturn in a retrograde orbit. During the early 20th century, research on Titan led to the confirmation in 1944 that it had a thick atmosphere, a feature unique among the solar system's moons. Modern NASA and ESA probes. Pioneer 11 flyby. Pioneer 11 made the first flyby of Saturn in September 1979, when it passed within 20,000 km of the planet's cloud tops. Images were taken of the planet and a few of its moons, although their resolution was too low to discern surface detail. The spacecraft also studied Saturn's rings, revealing the thin F ring and the fact that dark gaps in the rings are bright when viewed at high phase angle towards the Sun, meaning that they contain fine light-scattering material. In addition, Pioneer 11 measured the temperature of Titan. Voyager flybys. In November 1980, the Voyager 1 probe visited the Saturn system. It sent back the first high-resolution images of the planet, its rings and satellites. Surface features of various moons were seen for the first time. Voyager 1 performed a close flyby of Titan, increasing knowledge of the atmosphere of the Moon. It proved that Titan's atmosphere is impenetrable in visible wavelengths, therefore no surface details were seen. The flyby changed the spacecraft's trajectory out from the plane of the Solar System. Almost a year later, in August 1981, Voyager 2 continued the study of the Saturn system. More close-up images of Saturn's moons were acquired, as well as evidence of changes in the atmosphere and the rings. Unfortunately, during the flyby, the probe's turnable camera platform stuck for a couple of days and some planned imaging was lost. Saturn's gravity was used to direct the spacecraft's trajectory towards Uranus. The probes discovered and confirmed several new satellites orbiting near or within the planet's rings, as well as the small Maxwell gap within the C ring and Keeler gap, a 42 km wide gap in the ring. Cassini-Huygens spacecraft. The Cassini-Huygens space probe entered orbit around Saturn on 1 July 2004. In June 2004, it conducted a close flyby of Phoebe, sending back high-resolution images and data. Cassini's flyby of Saturn's largest moon, Titan, captured radar images of large lakes and their coastlines with numerous islands and mountains. The orbiter completed 2 Titan flybys before releasing the Huygens probe on 25 December 2004. Huygens descended onto the surface of Titan on 14 January 2005. Starting in early 2005, scientists used Cassini to track lightning on Saturn. The power of the lightning is approximately 1,000 times that of lightning on Earth. In 2006, NASA reported that Cassini had found evidence of liquid water reservoirs no more than tens of meters below the surface that erupt in geysers on Saturn's moon Enceladus. These jets of icy particles are emitted into orbit around Saturn from vents in the moon's south polar region. Over 100 geysers have been identified on Enceladus. In May 2011, NASA scientists reported that Enceladus is emerging as the most habitable spot beyond Earth in the solar system for life as we know it. Cassini photographs have revealed a previously undiscovered planetary ring outside the brighter main rings of Saturn and inside the G and E rings. The source of this ring is hypothesized to be the crashing of a meteoroid off Janus and Epimetheus. In July 2006, images were returned of hydrocarbon lakes near Titan's North Pole, the presence of which were confirmed in January 2007. In March 2007, hydrocarbon seas were found near the North Pole, the largest of which is almost the size of the Caspian Sea. In October 2006, the probe detected an 8,000 km diameter cyclone-like storm with an eye wall at Saturn's south pole. From 2004 to 2 November 2009, the probe discovered and confirmed 8 new satellites. In April 2013, Cassini sent back images of a hurricane at the planet's north pole 20 times larger than those found on Earth, with winds faster than 530 km/h, 330 mph. On 15 September 2017, the Cassini-Huygens spacecraft performed the grand finale of its mission, a number of passes through gaps between Saturn and Saturn's inner rings. The atmospheric entry of Cassini ended the mission. Possible future missions. The continued exploration of Saturn is still considered to be a viable option for NASA as part of their ongoing New Frontiers program of missions. NASA previously requested for plans to be put forward for a mission to Saturn that included the Saturn Atmospheric Entry Probe and possible investigations into the habitability and possible discovery of life on Saturn's moons Titan and Enceladus by Dragonfly.
Thank you for watching. Consider supporting the channel, leave a like and subscribe.